In this video, I'm going to talk a little bit more about coterminal angles. I already discussed coterminal angles briefly in my video entitled Angles. I'm going to elaborate. We're going to do some examples with radians as well. So again, the idea here is if I were to give you the angle, let's say 5 pi over 6, and ask you to find the position of that terminal side. Well, we would think about our quadrantal angles. And we know that the positive y-axis occurs at pi over 2. To get to the negative x-axis, it's pi. Negative y would be 3 pi over 2. And then, of course, the starting position, the standard position, starting position is on the line, the positive x-axis over here, the line theta equals 0, which is also the same as theta equals 2 pi. So we can place that angle very easily. 5 pi over 6 is between pi and pi over 2. It is closer to pi. In fact, it's 2/3 of the way between the two. And so that would be the position of the terminal side. But what if I had an angle like 17 pi over 3? Well, 17 pi over 3 is beyond 2 pi, so I can't place that very easily directly onto my xy plane here. I don't know where that's supposed to be because it's past 2 pi. So what we want to do is we want to bring that back into being between 0 and 2 pi, because we know that angles that end in the same spot, those coterminal angles, will always get us back around to the same position. So those coterminal angles we can get to by adding or subtracting 2 pi, and that will get us back to the same position. I just made up this position randomly. I don't know that's where the 17 pi over 3 is. Point is, I can add any number of circles on this. As long as I add a full rotation, it has to get me back to the same position. So let's work with this idea. We're going to subtract 2 pi to find our coterminal angle, as 2 pi is a full rotation in our plane. So 17 pi over 3, what I want to do is I want to subtract off a rotation to hopefully place it between 0 and 2 pi, so that way we can place it back onto that xy plane. So I'm going to subtract 2 pi. Well, to subtract 2 pi, I need a common denominator, and the common denominator would be 3. So we'd have 6 pi over 3. When we subtract that, we get 11 pi over 3. Well, that's better. It's smaller. It's a little bit easier to work with, but that's still not less than 6 pi over 3, which is a full rotation. So I'm going to need to find another coterminal angle. This is one coterminal angle. It's just not small enough for me to place it. So I'm going to subtract another 2 pi, which is still 6 pi over 3. When I subtract, I get 5 pi over 3. So this is another coterminal angle, and now this is something that is between 0 and 2 pi, and 5 pi over 3. It's very close to 2 pi. That would be right about here. It would be 2/3 of the way through the plane. So we can see that we had to subtract twice there in order to get our coterminal angle that we could actually work with. Now, keep in mind, if I wanted to find other coterminal angles, I could continue subtracting 2 pi as many times as I wanted, or I could actually have added 2 pi. That's another thing I can do to find the coterminal angles. Let me see if I can get that switch over to red. Not that it really matters. So if we added 2 pi, we would have 17 plus 6 pi, which would be 23 pi over 3. That's another coterminal angle. It's just larger than the one we started with. We can do this all day long. The point is there are infinitely many coterminal angles for any initial angle. Generally, we want to find the one between 0 and 2 pi because that is the easiest to place onto our plane. But what happens if we have something really, really large? So I'm going to make up a stupidly large number, 217,906 pi over 5. Now, if I wanted to plot this, I obviously can't look at this and know where it's going to be. And I could start subtracting 2 pi's, but I'm going to be at this for a while. This does not seem very efficient to me. So what I want to see is how many full rotations are there in this number here. This is our initial number. How many full rotations are there? So what I'm going to do is I'm actually going to divide by 2 pi, kind of. I'm going to see how many full rotations I have in there, but I'm going to view it in terms of common denominators again. The common denominator is 10 pi over 5. So what I'm going to do is I'm going to divide these, and I'm going to concentrate on those numerators because the denominators are the same. We could multiply by their circle, we cancel out the 5s, however we want to do it. But I'm going to take the 217,906, and I'm going to divide it by 10, because Again, the 5s are common, the pi's are common. So I'm just seeing how many times do I get a full rotation, how many times can I get 10 pi out of 5 out of this thing. And so when I divide, I get 21,790, and then there's, of course, a decimal there, 0.6. Now, I don't really care about that decimal. What this number right here is giving me is the number of full rotations. So if I were to have plotted this thing with all of its rotations, I would have whatever angle I'm going to end up with, but I would have 21,000 rotations. I would do this 21,790 times, blah, blah. Yeah, I'm not going to do this, obviously, take all day long. Or another way to think about it is that is the number of times I need to subtract 2 pi to get to my angle between 0 and 2 pi. Now, I don't want to subtract that 21,790 times. But what I can do is I can do this very efficiently by doing a little multiplication. I'm going to take 2 pi and multiply it by 21,790. And that will be subtracting. This is subtracting 2 pi, 21,790 times, because all multiplication is doing addition or doing subtraction a bunch of times. I want to use the common denominator still, so I'm going to use the 10 pi over 5. So when we multiply these, I'm just going to move that 0 over by 1. And so we will be left with 6 pi over 5. And that is a coterminal angle. And more importantly, it's a very useful coterminal angle because it is between 0 and 2 pi. 6 pi over 5 I know would be right about here. So what this thing would look like, it would have 21,794 rotations and it would have 6 pi over 5 past it. This would be a very useful coterminal angle. Let's do one last example. Let's take negative 21,301 over, say, 7. And let's put a pi there. And I want to graph this, which means I need to find its coterminal angle. Well, now because we're starting with a negative, I really need to build up to get to that positive so I can see where it falls between 0 and 2 pi. So I'm going to add 2 pi. I'm going to do it a bunch of times over. How many times? Well, to figure that out, we're going to divide. So I'm going to start by dividing this number by 2 pi, and I need a common denominator, 14 pi over 7. So I'm going to take negative 21,301 and divide it by 14. And let's see what we get. 21,301 divided by 14. And we get 1,521.5. And so what this tells me is there are 1,521.5 rotations till I get back up to the positive. So I'm actually going to round this up to this time 1,522 rather. I would do it in just a second where I round down. The last one I rounded down. And generally speaking, when I'm starting with a large positive angle, I'm going to round that number of rotations down. When I'm starting with a negative, I'm going to round it up because I want to put it back into the positive. If I said it, I made, let's say, 1.5 rotations in the positive direction, well, I just take off that one rotation. But if I made 1.5 rotations in the negative direction, by stopping at just 1, I would still have a negative distance to travel there. And so I'm going to go ahead and round that up. So let's take our initial angle of negative 21,301 pi over 7. Let's add to it 1,522 times 14 pi over 7. So again, I'm going to use my calculator to help me out here. We have negative 21,301 plus 1,522 times 14. Of course, pi over 7 are all common to both. And so we are left with, when we do this, 7 pi over 7, which of course we can simplify to just pi. It tells me actually this first number could have been simplified. That's not a bad thing to check. I just made these numbers up off the top of my head, and I happen to make up something that's divisible by 7. But so we find that pi is coterminal to this angle right here. Again, what had happened if instead of using the 1521 at 22, I'd use the 1521? Let's see, we'd have negative 21,301 pi over 7 plus 1521 times 14 pi over 7. So let's see what we get this time. It won't give me a wrong answer. It's just going to give me a different coterminal answer. So negative 21,301 plus 1521 times 14 gives me a negative 7, which simplifies to negative pi. And are negative pi and pi coterminal with one another? Can we add 2 pi or subtract 2 pi to get between them? Absolutely. These are coterminal. Which one is more useful? I don't know that there's a clear-cut answer on that. If I was going to graph the negative pi, I'd say, well, it takes me right here. There's my terminal position. If I was to graph the positive pi, I'd come to positive. It's going to give me the same position. So, if we're comfortable graphing these negatives, it's not terrible to have that negative. I generally, if I'm going to do all this work of finding a coterminal angle, I'm just going to make it positive. I think that's the easiest thing to do. But you can also use those negatives. The key is the most useful angle, or the easiest one, I shouldn't say the most useful, but the easiest one to graph, the easiest one to plot is the one between 0 and 2 pi. So coterminals allow us to get to those easier angles to plot. Now, there might be instructions that state we want it between 5 pi and 7 pi. And if we want it between 5 pi and 7 pi, well, we're just going to start adding pi's on these or subtracting pi's off of these to get to where we need to be. But we have division available to us to make the work a little bit faster, to help us out to get to the answer a little bit faster.